Number 14 is a question from statistics, and it reads, the table below shows the marks scored by 65 senior 3 students of Crested Secondary School during a mathematics contest marked out of 100. The table has two columns. The first column is for the score interval. The second column is for the number of students. The first column, we are given the limits. These are the limits. The score interval forms the limits. The column for the number of students forms the frequency. We shall analyze that. Question 1 says, using an assumed mean of 64.5, find the mean score. Part B is, we need to calculate the standard deviation. So, we are going to organize the given data in form of a table for us to easily manipulate and find the requested items in the question. So that table of analysis is what we call the frequency distribution table. You should be familiar with that, and in case you don't have enough knowledge, then visit our list of videos on this same channel, Vision Plus, for a full coverage of statistics. So we are going to organize our data in what we call frequency distribution table, or simply the frequency table, frequency distribution table. In the frequency distribution table, you can see here clearly that I have already stated the limits of the score interval. 40 in this case is the lower limit, 49 is the upper limit of this interval. For the second interval, 50 is the lower limit, 59 is the upper limit, and continues. So I wrote this to save our time, but let us go into completing the full table. I'm using my free hand to draw the table, but you can use a ruler. So we are given the number of students, and that is what we call the frequency. Frequency is just the number of times something appears. So it is the number of times a number or a given interval appears. It is the number of occurrences. So under frequency, which is the number of students, in the interval 40 to 49, we have 10 students. You write it there. In the second interval, 50 to 59, we have 20 students. In the third interval, we have 15 students. Here we have 15 students. 70 to 79, we have 5 students. 80 to 89, we have 10 students. And finally, 90 to 99, I did not copy that well. Should have been here, 90 to 99. We have 5 students. When we get the total frequency, it should give us the stated number of students, which was 65. Simply add them and we get the summation of frequency. So we have filled the second column of the frequency. Here we can get our summation of frequency. So from here we can get the summation of frequency here. which we write like this: summation of frequency. Then we add all those numbers: 10 plus 20, 30, plus 15, 45, plus 5, 50, plus 15, 65. It corresponds to the one stated in the question. So our frequency is 65 as it was stated. Now, we need to manipulate this table in a way that gives us what the question is. Since we are looking for the mean score using assumed mean, or it is also called the working mean or the working zero, we need to get we need to get the midpoint of the score, and the midpoint of the score is denoted by x. Our x here is the midpoint of our score. How do we get the midpoint? For the first interval, we say 40 plus 49 divided by 2. That's how we get our midpoint. We shall say 40 plus 49 out of 2. We do not need to show this one anywhere, but you simply press your calculator. So we add 40 plus 49, it gives us 89 divided by 2. I'm getting 44.5. So the midpoint for the first interval is 44.5. You write it in that manner. And then you go to the second interval, 50 plus 59 divided by 2. That is the midpoint, like we are getting a number midway between 50 and 59. And that gives us 54.5. And it continues for the rest of the numbers. 60 plus 69, we get the answer and divide by 2. That gives us the midpoint between these two numbers, and that will give us 64.5. I'm not going to explain the rest now. And then the next one, it will give us 74.5, 84.5, and then 94.5. After computing the first three values, you can see the trend that you are working with. So that is our midpoint. Why are we getting the midpoint? Because the midpoint is important in that it assists us in finding the deviation. And now from here, after getting the midpoint, then we get the deviation. How do we get the deviation? Clean this. We get the deviation by the formula that deviation is given by the midpoint minus the assumed mean. Our assumed mean, or the working mean, was given as 64.5. So we write it somewhere here on top. That our assumed mean, let me complete my table on top here. Our assumed mean A, let me write it here. Our assumed mean A is 64.5. So we are going to compute all this. We find the deviation by getting the midpoint, which is 44.5, minus assumed mean, which is 64.5. So we shall have 44.5 minus 64.5. That is negative 20. It is okay to get the negative number, don't worry. I have explained that myself in the detailed manner, and we have a list of videos. Yeah, this video will take time. I just encourage you to be patient, and we'll go through it step by step. And then continuing, for the second interval, the deviation becomes, our x is the midpoint. So here we shall have 54 minus 54.5 minus 64.5. That gives us negative 10. and then 64.5 minus 64.50. 74.5 minus 64.5, we get 10. 84.5 minus 64.5, we get 20. 94.5 minus 64.5, we get 30. We get 30. So we have got our deviation, which is the midpoint minus the assumed mean. I'm coming up with this table slowly. That's why. Okay. After getting the deviation, then we need to get FD. Why are we getting FD? FD is the frequency times the deviation. We are getting FD because it is part of the formula of assumed mean. We know that when we are finding mean using the assumed mean, we say our mean x bar equals to the assumed mean plus the summation of FD out of the summation of F. This is the formula. So we need to get all these values such that we substitute them in the formula for finding mean using the assumed mean. I will quote this formula again when we reach down there. So how do we get FD? FD is the frequency times the deviation. That means for the first case here we shall have 10 times negative 20. That gives us negative 200. And then 20 times negative 10, we again get negative 200. 15 times 0, we get 0. 5 times 10, we get 50. 10 times 20, we get 200. And finally, 5 times 30, we get 150. That is our FD, frequency times the deviation. So from here, let me complete my column here. In the formula, we are supposed to get summation of FD. So put here summation of FD. And then we add all these negative 200, negative 200, we add all the values in this column. So on adding, let me press my calculator. On adding, I'm getting 0. Because here we shall have negative 400 and also down here we shall have positive 400. So the summation of FD is 0. And if you look at the question, we also need to find the standard deviation. The formula for standard deviation wants us to find FD squared. So let me include the column here for FD squared. If you know the formulas, then you can easily manipulate the table. But this table is not fixed. It is flexible. In case you have realized you need something, you just come and add its column. The arrangement is not fixed. It is flexible. Just that first, the score and the frequency are the determinants of the results. So you put them first to guide you. How do you get FD squared? Now, if you look here, we have F. And here we have D. And then again here we have FD. So there are two ways. One is someone can get the values of deviation times the values of FD, because that becomes D times FD, and that gives us FD squared, and you shall have obtained your FD squared. Or someone can get F and then times, they get the value of D and they square it. So you say F times negative 20 squared. They give the same results. When someone says it is F times D squared, we still get FD squared. We have a full playlist on that, so you get time and visit. So I'm going to use the D and FD to find FD squared, such that I just say negative 20 times negative 200, I'll get positive 4,000. Press the calculator. I say negative 10 times negative 200, I get positive 2,000. 0 times 0, I get 0. 10 times 50, I get 500. And then 20 times 200, I get 4,000. 30 times 150, I get around 4,500. Press the calculator. So that is our FD squared. FD squared. These are the things that the mean using assumed mean and the standard deviation require. So our summation here now of FD squared, you simply add all these values. So we shall have here 6,000, 6,500, 10,500, and then 11,000, 15,000. I'm getting 15,000 here. I'm getting 15,000. So here we write 15,000. That is the summation of FD squared. So basically, this table has taken us time. I did not want to draw it and then I come here and just explain, but I wanted to give you highlight on how you come up with a table. Your table should include what you need to use. And in case your table is not exhaustive and you have reached the questions, but you have found where you needed to add something, you just come back and add it in this free space. But it is good to plan properly so that your table fits in the given space. So that is our table. So for us now to answer, to find the mean using assumed mean, that is our part A now. Our mean x bar using assumed mean is given by the assumed mean itself plus the summation of FD over the summation of F. And then we substitute. We were given assumed mean as 64.5 plus the summation of FD. This is our FD column and the summation was 0 here. So plus 0 over summation of F is just the total frequency. That is the total number of students in the class divided by 65. And then you compute. What is, here we shall have 64.5 plus 0 divided by 65, we get 0. And therefore when we add here, we shall have 64.5. This is our mean using the assumed mean. So this is the answer for the first part. After drawing this table, the rest of the questions become very easy and straightforward. Most students face challenges drawing the table, but after getting the logic, they easily understand. Calculate the standard deviation. Roman B, part B rather, the standard deviation. What do we know about the standard deviation? Standard deviation, it is given by sigma. So standard deviation sigma equals to the square root of what we call variance. New terms are coming in. Please go and watch our videos. We have what we call variance. But how do we get the variance? Now the variance has a formula. That variance equals to summation of FD squared over summation of F minus summation of FD over summation of f, but both of these are squared. This is the formula for getting the variance. Please, this symbol means summation. This one means summation. It is just adding mass numbers. Adding like a collection of numbers. If I say mass numbers, those ones who know chemistry will argue with me because it has a different meaning. So this is how we get the variance. So simply, our standard deviation sigma is the square root of variance, which is given by the whole of this expression. So let me go to the next page. Therefore, get the variance and then I substitute for the value of the variance. So our variance, we have said, it is the summation of fd squared out of summation of f. So you come and look for the summation of fd squared. It is here, 15,000. So we shall say, we shall have 15,000 divide by the summation of f, which was 65 students, minus, open the bracket. We look for the summation of fd. Summation of fd was 0, as you see here. So 0 out of is still the summation of f, which was 65, but this side says squared. It is not a must for the summation of fd to be 0. It depends on the number and the value of the assumed mean. And now from here, we simplify this. We shall have, I'm dividing this side, 15,000 divided by 65, I'm getting 230.7692, right, 4 decimal places, minus the whole of that side becomes 0, and therefore our variance is 230.7692. That is just our variance. But remember, our standard deviation sigma equals to the square root of variance. And therefore here we just substitute for the value of variance. That is 230.7692. And then you press the calculator. Get the root of your answer. I'm getting 15.1901. Yeah. So this is our standard deviation. Therefore, our standard deviation sigma equals to 15.1901, and that is the solution to part B for the standard deviation, and that is the solution for using the assumed mean. So please get time. I have made a full list of videos just for you to understand statistics. When you visit there, you will familiarize yourself with how this table works, and you will master all the formulas that are used, and even you'll go ahead to know the definition of terms like the standard deviation, the variance, the mean, plus other terms like the mode, the median, and even how to plot graphs. It is very, very understandable, and you have the right to complain because of the time we have taken. But I thought it would be very, very significant for you to go through it step by step as we have done. A gentle reminder, this is Vision Plus, and these materials are designed to help you succeed. Share them with your friends, your classmates, and have a good day.